Hello everybody, so in this lecture I'm gonna give you another example of integration. So we have an integral I, a definite integral from virtual integral, in fact, from 0 to plus infinity, with exponential of minus ax times sine of bx over x dx, in which the parameters a and b are some positive real and real arbitrary real numbers, parameters. So this integral is in fact a function of a and b, and I of a and b is what we are searching for. So in order to calculate this integral, the approach that we are using is to consider these two terms and the fact that the integral of cosine of bx with respect to b, so this is an indefinite integral. This is exactly sine of bx over x. So this term here, this fraction here, is exactly the integral of cosine of bx with respect to b. So if I define another integral a prime of a and b, which is absolutely not the derivative of a, this is another function a prime. If I define this function as the integral from 0 to plus infinity of exponential minus ax times cosine of bx with respect to x, so I will define this integral I prime like this. If now I calculate the integral of this function a prime with respect to b, what I will have is in fact the integral of this function from 0 to plus infinity exponential minus a times x cosine of bx dx. If I simply change the order of these two integral signs, I will simply have integral from 0 to plus infinity of the exponential of minus ax times the integral of cosine of bx times db, and finally times dx. This integral, as we have said here, is sine of bx over x, and finally we will have the integral from 0 to infinity exponential of minus ax sine of bx over x dx, which is exactly the integral of I prime with respect to b. So the question is now if we can determine the integral I prime and after that this integral. So we have a two-step problem. The step one is to calculate I prime using either the 2 times integration by parts, or more simply the fact that in fact I will use the complexifying of integrals. So cosine of bx in fact is the real part of exponential of I bx. This is cosine of bx plus I sine bx, so the real part is cosine of bx. And the integral I prime, it will be like this, which will be the real part of the integral from 0 to plus infinity exponential of minus ax times exponential of I bx dx. So I will focus on this integral here So the integral from 0 to plus infinity of exponential, if I factorize x, I will have x times ib minus a dx. The result is really straightforward. So exponential of x times ib minus a over ib minus a from 0 to plus infinity. In plus infinity, we have a term exponential of minus ax, and due to the fact that a is a positive real, exponential of minus ax tends to 0 in plus infinity, and the whole term tends to 0, minus this for x, this term evaluated at x equal to 0, which is 1 over ib minus a, or simply 1a minus ib. And the problem is I prime is in fact the real part of this guy. So 1 over a minus ib is in fact equal to, if I multiply the numerator and the denominator by the complex conjugate of this term, which is a plus ib, I will have a plus ib over a2 plus b2. And finally, a I prime here, which was in terms of a and b, will be simply the real part of this guy, which is simply a over a2 plus b2. And the second step is to calculate the integral of I prime with respect to b, because the problem, the integral, was this one. This is exactly the integral of I prime with respect to b. So this function I prime, the integral, so the question, the answer in fact is the integral of I prime with respect to b, or the integral of a over a2 plus b2 with respect to b, which is simply tangent minus 1 or arctangent of b over a. So the answer is in fact tangent minus 1 of b over a. And in this problem, we have seen that if we consider a given part in the integrand, and we will see that this integrand can be written as the some indefinite integral. We can have another integral in which whose integral in fact give us the answer. So in order to calculate the a prime, we have used the technique of complexifying the integrals, and in a second step, the integral of I prime with respect to b, which was straightforward. Thank you for your attention.